everyone. My name is Katrina Whipple, and I'm an instructional coach at Carter Middle School. It is so good to be with you today, and we are going to do some 8th grade math together. Today, we are going to review the equation of a line in y equals mx plus b form, and we'll talk about the slope and y-intercept, and then we'll do a math task together. So let's go ahead and get started.
So let's talk about graphing lines. Y equals mx plus b is the equation of a line. In this form of the equation, m represents the slope. The slope of a line is a number that describes how steep the line is. Slope can be a positive or a negative number, and it is represented as the rise over the run. So every time we think about this equation, we should just remember that m represents the slope. Another key piece of information in y equals mx plus b form is b. B represents the y-intercept. The y-intercept is the place when the line we are graphing crosses the y-axis. So if we think about a coordinate plane with an x and a y-axis, the y-axis is the vertical one. So when we graph a line, it will cross that y-axis at a specific point. So where that line crosses the y-axis, that point is the y-intercept. So let's take a look at 3 different examples. In this first example, the first thing that I think about doing is writing the slope-intercept form above my equation. So when I write y equals mx plus b, I notice that the 2 is my m. So that means that the slope of the line y equals 2x is 2. Now sometimes it helps to go ahead and think about that as a unit rate and put it over 1. So the slope could equal 2 or 2 over 1. Now when I'm considering this equation, y equals 2x, I notice that nothing is added. So I can assume that I could add 0 without changing the equation. So that means that my y-intercept for this equation is 0. So now let's use this information and graph this linear equation. So I'm going to start with my y-intercept. It crosses the y-axis at 0. So the slope is 2 over 1. So that represents a rise of 2 and a run of 1. And I'm going to put a point there. I'm going to continue to do this a couple of times. Now that I have a few points there, let's go ahead and connect those points because this is a linear equation. We'll extend that line in both directions. So now as I think about this, I could continue on from any of these points and do a rise of 2 and a run of 1, and note that my next point is still on this line. All right, so let's look at another example. So again, the first thing I think about is writing y equals mx plus b above my equation. This helps me to connect the different pieces of the equation that I was given with the form that I am familiar with. So as I look at this, I note that m, my slope, is again 2. So the slope is either 2, or I could write it as a unit rate as 2 over 1. So now this time, I see that there is a minus 3 here. So that is my y-intercept. I have to make sure to bring the negative that is in front of that 3 along as part of my y-intercept. So the y-intercept is negative 3. So now that we have all of this information, let's go ahead and graph it. I'm going to start with the y-intercept and plot that point. Then I'm going to use my slope, and I'm going to rise 2, run 1, and put a point. And I'll continue this a couple of times. So now that I have a few points on my graph, I'm going to go ahead and I'm going to connect those points, because this is a continuous equation. This is a linear continuous equation. And I can see that if I rise 2 and run 1 more, that point is on my line. So I know that I've graphed my line correctly, and we are ready to move on to another example. So if you're watching on YouTube, this is a great time to pause your video and try this one on your own. So the first thing I think about is writing y equals mx plus b. So as I look at this one, the number in the place of m is a negative 2. So for this example, the slope of this equation is negative 2. Or I could think about it as a unit rate and say it's negative 2 over 1. My y-intercept this time, it is a positive number. It has the plus there, just like plus b. So my y-intercept is 3. So now I'm going to go ahead and I'm going to start graphing this equation. I'll start by finding my y-intercept and putting it at 3. So the slope of this line is negative 2. So that means instead of rising up 2, I'm going to go down 2. So down 2 and over 1. And down 2 and over 1. So now I'm going to connect those points with a line. And here we have graphed another linear equation. All right, so let's look at this performance task. To make MP3 players, a cost estimator determined it costs a company $1,500 per week for overhead and $45 for each MP3 player made. Part A says, define a variable to represent the number of players made, then write an equation to represent the company's total cost, C. So when I think about the variable that I have and its relationship to the total cost, in order to figure out how much the total cost will be, I have to know how many players we are going to make. So I'm going to let P equal the number of players. Now, as I think about the relationship between the number of players and the total cost, I have to think about an equation. Well, we just talked about equations in y equals mx plus b form, so let's draw on that understanding to see if we can figure out this equation. So the cost is going to be equal to $45 for each player plus an additional $1,500 that it costs for the company to run their factory. So the equation that I'm going to use is C equals 45P plus 1,500. All right, so part B of this problem says 1 week the company spends $5,460 making MP3 players. How many players were made that week? Show your work. So I need to go back and I need to think about 5,460. That represents the cost? Well, we just wrote an equation that we can use here. So let's use this equation. And because the cost for the entire week was $5,460, we're going to put that in place of C. So then we'll copy the rest of the equation down and we will be able to solve it. So if you remember how to solve this equation, go ahead and fast forward through and we'll meet you on the other side. So to solve this equation, first we're going to subtract 1,500 from both sides. When we do that, we get 45p will then equal 3,960. So now, to get p by itself, we need to divide both sides by 45. And when we divide both sides by 45, we find out that p equals 88. So we'll go right back over here and answer our question that in this 1 week, the company made 88 players. All right, so now let's look at part C. If the company sells MP3 players for $120, how much profit would it make if it sold 80 players in 1 week? Explain how you found your answer. So the first thing I'm going to think about is profit. The way that I find profit is I think about my expenses, and I also think about my sales. And so the difference between the sales and the expenses, if it's a positive number, is your profit. So the first thing that I need to do is I need to find out what were the expenses for this company the week that they sold 80 players. So I'm going to go back and use my equation again, except that this time I don't know the cost. I know the number of players. So I'm going to write in my equation 80 players, so 45 times 80 plus $1,500. And that's going to give me my total cost or my expenses. So now I'm just going to go through and calculate all of that, 45 times 80 plus 1,500, and I find that it is $5,100. So now I need to figure out what did they make on sales. So if they sold 80 players for $120 each, I know that they made 80 times 120 is $9,600. So I see that there is a difference between the sales and the expenses. So I'm going to take those two numbers and I'm going to subtract them. The amount beyond the expenses that the company has is their profit. So $9,600 minus $5,100 gives me a profit of $4,500. So now let's go back and type up that answer. So the profit was $4,500. And we found this by subtracting the expenses from the sales. So if you're watching this video on YouTube, this is a great time to pause the video and go try and do this next problem on your own. So this problem says a train from Portland, Oregon to Los Angeles, California travels at an average speed of 60 miles per hour and covers a distance of 963 miles. Susanna is taking the train from Portland to Los Angeles to see her aunt. She needs to arrive at her aunt's house by 8 p.m. It takes 30 minutes to get from the train station to her aunt's house. Part A. By what time does the train need to leave Portland for Susanna to arrive by 8 p.m.? Explain how you got your answer. As a part of your explanation, write a function that you used to show your work. As I look at the key information in this problem, I notice that there is a rate, and it is miles per hour. I also notice that it's talking about distance in a number of miles. And then the next piece of information that it's asking me for is a time. And so because I have a distance and a rate, and I need a time, I'm going to use the distance formula that we've learned, which is distance equals the rate times the time. So now I can go back and I can figure out how long it's going to take this train ride by filling in the information from my problem. It says that the distance is 963 miles and the rate is 60 miles per hour. But I do not know how many hours this is going to take, so I'm going to need to solve this equation. So in order to solve this equation, I simply divide both sides by 60. Now, because we're talking about time, this is a great opportunity to do long division, and remember that we can use our remainder to make a fraction as a part of the next unit. So 963 divided by 60. Well, 60 goes into 90 one time. 96 minus 60 is 36. Bring down that 3. 60 goes into 363 6 times. And then we'll subtract, and I get a remainder of 3. So I know that that gives me 16 hours and part of another hour, and that part is 3 minutes. So I know that it's going to take me 16 hours and 3 minutes on the train. But that does not get me to my aunt's house. I need to remember to use this 30 minutes because it takes 30 minutes to get from the train station to her aunt's house. So I need to add that extra 3 minutes so that I can ensure that I get to my aunt's house on time. So 16 hours and 3 minutes, and I want to add that 30 minutes. So the total travel time is going to be 16 hours and 33 minutes. So now I'd have to think about how am I going to go from 16 hours and 33 minutes to figure out what time I need to leave. Well, I need to go back in time from 8 p.m. back 16 hours and 33 minutes to determine what time I should leave by. When you subtract with time, you have to remember several things. You have to remember that you're going out of 12. So I thought I would show you this clock. So let's just take this clock and we're going to go backwards. We started at 8 p.m. and we're going to go backwards 16 hours and 33 minutes. Well, once I've gone from 8 p.m. back to 8 a.m., I've gone 12 hours. So I know that from here, I still have to go back another 4 hours and 33 minutes. So let's pull that back. This is hour 13, hour 14, hour 15, 16, and now I need to go back another 33 minutes. So pulling that hand back around 33 minutes is going to get me to 3:27 a.m. So in order to get to her aunt's house, she has to leave at 3:27 a.m. So let's go ahead and type that up. So we're going to use the distance, rate, time formula. And so in order to do that, we added the extra 30 minutes to the 16 hours and 3 minutes, and then counted backwards from 8 p.m. to ensure that we would arrive at her house on time. All right, so in part B, it says Susanna does not want to leave Portland later than 10 p.m. or earlier than 6 a.m. Does the train in part A meet her requirements? If not, give a new departure time that would allow her to still get to her aunt's house on time. Find the arrival time of that train. So if I'm thinking about this, 3:27 a.m. certainly does not meet her requirements. But if I waited to catch a 6 a.m. train, I would get there after 8 p.m. So no, the train leaves too early in the morning for her. But in order to get there on time, she is going to have to take an earlier train and leave the night before. So now we need to think through, how are we going to find out the arrival time of this new train? So we know that she needs to leave at 10 p.m. And so if I think about the time for the train still has to be 16 hours and 3 minutes. So I need to think about, from 10 p.m., I'll need to go forward in time. In the last part, we had to go backward, but this time we're going to move forward in time, and we're going to move forward in time 16 hours and 3 minutes. We're going to use 16 hours and 3 minutes because it wants the arrival time for the train, not the total travel time. So let's take a look at our clock again. So I've set my clock to 10 p.m. and we need to move forward in time 16 hours and 3 minutes. So again, as I move around the clock, I can go 12 hours and I will be at 10 a.m. So here we are, we've gone 12 hours and it is 10 a.m. So we need to continue to move forward all the way up to 16 hours and 3 minutes. So there's the 13th hour, 14, 15, 16. Right there we have 16 hours and 3 minutes. One more minute here. All right. And so we can see that at 16 hours and 3 minutes, we will arrive at 2:03 p.m. Okay, so we already knew that she needed to take a 10 o'clock train because she doesn't want to leave after 10. And so she will arrive in Los Angeles at 2:03 p.m. the next day.
Thank you so much for taking your time today and doing math with me. I hope that there was something that you remembered. And if you have any questions about the content that we covered, please contact me or your teacher because we're here to help you and we want to make sure that you continue to learn and grow while we're away. I hope you have a great week. Goodbye.